All right, so we are continuing our work with trigonometry. We are going to be finding the lengths of sides now. So we're going to look at this first triangle, and this is going to be familiar to you. You should have done this in geometry. We look at our angle, and then with respect to this angle, would this be the opposite, adjacent, or hypotenuse? Opposite, and this would be the hypotenuse. So then I think, okay, with what I know about SOHCAHTOA, I'm given the opposite and the hypotenuse, so therefore I know I'm going to use the sine ratio. So the sine of my angle is going to be equal to the opposite over the hypotenuse. So therefore, if I want to solve for this opposite side, I'm going to want to cross multiply. So this is over 1. So I'm going to get x equals 25 times the sine of 64 degrees. So to find this answer, we're going to want to go to our calculator, check the mode, make sure we're in degrees, and then we're going to want to do the sine of 64 times 25. And we're going to round these to the nearest tenth, and this is an approximation, so 22.5. All right, you did that kind of thing last year, right? Okay, let's do another one here. So looking at our angle, Megan, what's the x going to be? Good. And the 12? And so what are we going to use? Tangent. So we're going to do the tangent of our angle equals opposite over adjacent. So to solve for x, we're going to cross multiply. So we're going to have x is going to be equal to 12 times the tangent of 47. So we're going to type that in. And we get 12.9. Can somebody explain to me why that makes sense? Yeah, Luke?
Because it's almost 45 degree angle, so yeah, it's supposed to be.
Exactly. This angle is actually 43 degrees, so these are both very close to 45, so these should be very close. But this one's a little bit bigger angle, so across from a larger angle should be a larger side. Okay? All right, let's do one a little more complicated. 3 is the same type. We're not going to do that one, but let's look at 4. So on 4, we look at our angle. This is our opposite, and this is our adjacent. So because I'm using opposite and adjacent, I know I use the ratio tangent. So I do tangent of 35 degrees equals opposite over adjacent. Now when I cross multiply here, I multiply both sides by x. So I know that x tangent of 35 is going to equal 9. So therefore, to solve for x, I have to divide by the tangent of 35. And so that's what x is going to be equal to. So when the x is in the denominator, we have to be a little more careful. These were pretty quick, but when x is in the denominator, I had to cross multiply and then solve for x. And so now it's going to be 9 divided by tangent of 35, and that gives us 12.9. What can I do to make this go a little quicker? What did it end up being? It ended up that x was 9 divided by tangent of 35, right? So what do you think we could actually do with these two values? Just switch them, and you can make the problem go a lot quicker. But you only want to do that when that x is in the denominator. Let's do another one where x will be in the denominator. This one would be like that. So this angle right here is the one we're looking at. This is our opposite. This is our hypotenuse. Okay, so which one are we going to use, everyone? So we're going to do the sine of 63 equals opposite over hypotenuse. So now I know the quick way to do this would be to switch these two. So now I know that x is just going to be equal to 27 divided by the sine of 63. If you don't understand that, then you should write it all out, but that's the shortcut way. And that is 30.3. And what should always be the longest side of any triangle? Hypotenuse. So if I had gotten an answer here that was less than 27, I should stop and say, okay, that wouldn't make sense. So I'd want to rework the problem. What about number 6? What if I said you really don't even have to set this one up the way I've been doing it? It's a 30, 60, 90. So you would have to read the directions closely. If I said to find the exact answer, if it said exact, you cannot do it this way. Let me show you how most people would do it. They look at this and they're like, okay, this is my adjacent, this is my hypotenuse. I'm going to do cosine of 30 equals adjacent over hypotenuse. X is on the bottom, so I can do 18 divided by cosine of 30. And that my answer is 20 point, and people just write all these numbers. They're like, okay, my exact answer is 20.78460969. Is that an exact answer? No. Okay, no matter how many numbers I write, it's still not exact. So even if I write every single number, that is not correct for the exact answer. How would I find the exact answer? Divide by what first? Okay, so I'd have to do 18 divided by radical 3. What's that going to be? So this is 6 radical 3. And then how do I go from the short leg to the hypotenuse? So my exact answer then is 12 radical 3. Now, this would be nice to check my answer, right? I can type in 12 radical 3. Oh, okay, good. So that's the correct answer. Yeah, Kelsey.
So we can only find like the exact if it's or like the 45, 45, or 60 degree?
Could, yes, that's correct. And the only reason why is because those are what we call special triangles, because they have these special ratios all the time. But there is no special ratio if it's like 35 degrees. There's no, I mean, it's always going to have the same ratio, but I can't say, oh, okay, this is, what's 12.9 divided by 9? Okay, I would have to say, oh, this side is always 1.433333 times the other one. You see how that doesn't really make any sense? It's not going to give us an exact one. So these are the exact. Okay, so if you know the sine, cosine, or tangent ratio of an angle, you can use the inverse of the ratio to find the measure of the angle. So if sine theta equals x, then theta is going to be equal to sine to the -1 of x. All right? And I think you guys have done this kind of thing before as well. All right, so let's look at this problem here. I'm going to look at my theta. This is opposite. This is adjacent. I know I'm going to use tangent. So tan theta has to equal opposite over adjacent. So I'm going to have to do second tan to get to inverse of 8 divided by 14. And that's going to give me this answer. So we're going to round this to the nearest tenth, so it's 29.7 degrees. But before we go on, I want you to listen to this. This is going to be new. There's another way to measure angles that's called degrees, minutes, and seconds. And what happens is every degree can be broken down to 60 minutes, just like every hour can be broken down into 60 minutes. Every minute of a degree can be broken down into 60 seconds. So if I want to be really exact with this, I could write it in degrees, minutes, and seconds. I want to show you where that key is located. It's located under angle. Do you see angle on your calculator in the third row, second column? You're going to have to hit second to get to it. And then there's this key DMS. That's degrees, minutes, seconds. Go ahead and push that, and then push enter. So now it's telling me what another name is for this angle. 29 degrees, 44 minutes, and 42 seconds to the nearest second. So this is just a more accurate way to measure angles. When you were in geometry last year, you were allowed to just round it. Now we're going to write it more accurately, degrees, minutes, and then to the nearest second. Okay? Every time you're going to do that. Even though the directions say round to the nearest tenth, I want you to write it in degrees, minutes, and seconds. All right. So on this one, adjacent, hypotenuse. So cosine, so go ahead and type that in and put it in degrees, minutes, and seconds on your own. You should have gotten 18 degrees, 11 minutes, and 42 seconds. And then I should see if this kind of makes sense. Well, if I had 30 minutes, that would be half of a degree. So I know that I don't even have half of a degree, so therefore this makes sense. So it would be about like that. All right, now let's go to the other side. We're not going to do 9 and 10. They're just like the ones we've been doing. So now we're going to do some word problems. Angle of elevation, angle of depression. All right, angle of elevation first. If you have a person standing here, and if they look straight out and then up, this right here is what we call the angle of elevation. It always has to be based off of the horizontal. So this guy's looking straight out and then up. That's called the angle of elevation. If we have a person who's up higher than the object, like look at this person. They're up sitting here high, and then here's what they're looking at. He's looking straight out and then down. That's called the angle of depression. Okay? So it always has to be off the horizontal. Here's where people mess up. People always want to call this right here the angle of depression, but it's not. It has to be off of the horizontal. Okay, so when we get to that, you'll want to think back to that. Let's read the first one. The angle of elevation from a fishing boat to the top of a lighthouse is 5 degrees. If the top of the lighthouse is 161 feet above sea level, how far is the boat from the lighthouse? All right, so on these, you're always going to want to draw a picture. So the angle of elevation from a fishing boat, so I'm going to draw a boat, to the top of a lighthouse. I'm not a good artist at all, but there's my lighthouse. Okay, so this angle of elevation from the boat to the top of the lighthouse is given as 5 degrees. If the top of the lighthouse is 161 feet above sea level, where's that going to go? A, B, or C? B. This is 161 feet. This would have to be a right angle. How far is the boat from the lighthouse? What am I trying to find? A or C? A. The boat is traveling in the water. The boat doesn't go like this to get to the lighthouse. It goes this way. So we're going to be finding this. Okay, so which trig function are we going to use? Tangent. So tangent of 5 degrees equals 161 over x. See if you can quickly type that in. So here's what I got. So why, that doesn't seem right, does it? Or does it? That's an awfully big number. Why would this number be so big? Go ahead.
Because your angle's so small.
Yeah, this angle's very small. It's almost 0. It's close to 0. So this side is 161. What's this angle here? 85, right? So this is going to be a much longer side then that's going to be. So it's okay. It seems logical. All right, let's look at the next one. The angle of elevation from the bottom of a slide to the top of the slide is 44 degrees. If the top of the slide sits 16 feet above the ground, find the length of the slide. Assume it is a straight slide. All right, so we need to draw a picture. So I'm going to draw my slide. I'm going to change the perspective to go this way now. Doesn't matter. I'm just going to change it up a little bit. So assume the angle of elevation from the bottom of the slide to the top of the slide is 44 degrees. Where does that 44 degrees go? A, B, or C? C. If the top of the slide sits 16 feet above the ground, is that A, B, or C? A. Find the length of the slide. Am I trying to find B or C? C. And I want to make this problem a little tougher. I'm going to write this angle in degrees, minutes, and seconds. So we're going to say this angle is 44 degrees, 30 minutes, and 40 seconds. And I want to show you how to do that now. Okay, so we have our angle. This is our opposite, and this is our hypotenuse. So what are we using? So we have to do the sine of 44 degrees, 30 minutes, 40 seconds equals opposite over hypotenuse. All right, so I know that I can just switch these two. So it's going to be 16 divided by the sine. Now watch this closely how you put this in. I have to do 44. I have to go under angle to get degrees. Now I have to do 30, and I have to go under angle to get my minutes. But here's where it gets weird. If I want to do 40, under angle there's no seconds. And it's so strange. I don't know why they did this. Seconds is here above the plus sign. See how it's seconds is right there, the double apostrophe? So I'm going to do alpha to get that. So that's the way I have to type that in. So I had to do 16 divided by that. Now I push it, and it's 22.8. All right, does that make sense that that would be 22.8? What's this angle about?
45.
It's almost 45. How would I go from a 45 to the hypotenuse? So I'm going to check this to see. Oh, look how close that is. See how it makes sense then? All right. Everybody find those minutes and seconds all right? Okay, let's do another one. A 10-foot ramp is used to unload furniture from a truck. If the back of the truck sits 3 feet above the ground, find the measure of the angle that the ramp makes with the ground. Try drawing your picture. Okay, so here's my picture. I've got my ramp, my truck. So if the back of the truck sits 3 feet above the ground, so this is going to be my 3, depending on where you have it, find the measure of the angle that the ramp makes with the ground. What other piece of information did they give me? 10. Where's the 10 go? On the what? Hypotenuse. Good. So we're going to find this angle, find it very specifically in degrees, minutes, and seconds. And you should have gotten for theta approximately 17 degrees, 27 minutes, and 27 seconds. Anybody get it? All right. So now we're doing angle of depression. By the way, before we leave angle of elevation, if our problem had been just like this picture, and I found this to be, say, 100 feet, what would I have to add on to find the total height of that light tower, that lighthouse? The height of the person, right? So in your homework, sometimes they tell you the height of the person and in the angle of elevation. So you'll be able to find this, but you would have to add on the height of the person to find that total height. Just keep that in mind. All right, let's do some angle of depression. A fire is spotted from the top of a 120-foot tall fire tower. If the angle of depression to the fire is 19 degrees, how far is the fire from the base of the tower? All right, so we have a tower right here. A fire is spotted. So we'll put the fire here on the ground. Okay, so here's our triangle. 125-foot tall tower. Where's it go? A, B, C. 125-foot tower. A, B, or C? A. Okay. If the angle of depression to the fire is 19. Okay, here's where it gets a little tricky. Angle of depression is not this angle. Because angle of depression means we have to be looking straight out and then down. This is the angle of depression right here. But based off of what we talked about earlier, where else could I put that 19 degrees? A or B? B. See this diagonal right here? This Z shape? This must be a rectangle. These are parallel. Alternate interior angles must be congruent when we have parallel lines. So that's 19. What are we trying to find? How far is the fire from the base of the tower? C or B? B, yes. C is the hypotenuse. That's not the base. All right, so then to set this up, I'd have to look at my angle. This is my opposite and adjacent. What are we going to use? Tangent. So we do tangent of 19, and we're not even going to finish it. We're just going to set it up. That would be our setup. All right, let's go to 15. An airplane is flying at an altitude of 8,900 feet over water. The pilot spots a raft floating in the water at a 28-degree angle of depression. What is the horizontal distance from the airplane to the raft? I want to take out the word horizontal. What is the distance from the airplane to the raft? And I want to make this angle, they're very specific. Let's say it's 28 degrees, 30 minutes, and 22 seconds. All right, so how's this going to go? Well, we have an airplane up in the air. I cannot draw an airplane, so I'm just going to put A for airplane. Altitude of 8,900 feet over water. Okay, so here's the water. So our airplane, 8,900. Is that more or less than 2 miles?
Oh wait, 2 miles?
It's less than 2 miles. How many feet are in 2 miles? All right, there's 5,280 in 1 mile, so 2 miles then would be, right. Okay, so this is in between 1 and 2 miles. All right, the pilot spots a raft floating in the water at a 28-degree, 30-minute, 22-second angle of depression. Okay, so here's the raft. I'm not real sure how they would see that raft from that high up, but okay. So what is the distance from the airplane to the raft? Now, since I changed the wording here, what is it we would be trying to find? Hypotenuse, right. If it asks for the horizontal distance, then we would be finding this. But it really doesn't make sense to ask for that. To find the actual distance from the airplane to the raft, how far apart are they? We're going to find this. Call this C. Okay, try this on your own. Did you get it? 18,648.4 feet. Okay. And then this last one, we're just going to set up. Maybe we'll solve it. Let's see. Max is sitting in the stands of the baseball stadium. He catches a foul ball and decides to throw it back to a player standing on first base. If the horizontal distance from Max to the player is 61 feet and the ball travels 76 feet, what is the angle of depression from Max to the player? All right, so Max is up here in the stands. Maybe the stands kind of look like this. Here he is. And there's a person here at first base. And so here's what we're looking at. Okay, so if the horizontal distance from Max to the player, so we're going to need to drop this down. Okay, so what's this, where's this 61 going to go, the horizontal distance, A, B, or C? A, B, or C? A. This is 61. It's this horizontal distance. And the ball travels 76 feet. Where's that going to go, A or C? C. And then find the angle of depression. What could you find to find the angle of depression? Would you want to find this angle? No. What about this angle? Yes. That angle is actually the same as that angle of depression. And go ahead and find that in degrees, minutes, and seconds. And that's what you should get. Okay, questions?